Welcome to this channel Chemistry Made Easy by Dr.ARM. Today we will see the next point of ionic bonding in chemistry and structure. That is, our point of interest is applications of Fajan's rules. So last time we have seen what are Fajan's rules, and today we will discuss the applications of these Fajan's rules. So first of all, we will discuss the solubility. So this solubility we can consider for inorganic solvents. When the solubility in organic solvents is more, it means the solubility of such compound is less in water or polar solvent. So if we take the first example, that is AgF, AgCl, AgDr and AgI. So here we find that the covalent characters are increasing in this direction, and solubility in organic solvent also increases in the same direction. Now we can consider another example, that is Kf, KCl, KBr and Ki. So here also you will find the same trend, that is same thing. The solubility in organic solvent increases in this direction. So in this way we can have number of such trends in solubility. Now we will see next, that is second example or second application, we can say. Second application, that is solubility in ether. Solubility in ether. Here we can find, or we will take two examples, that is FeCl3 and another is AlCl3. So here this FeCl3 is having cation with 18 electron system. This has 18 electron system, whereas aluminium has 8 electron system, and therefore this FeCl3 is more soluble. FeCl3 is more soluble in ether, whereas it is less soluble in ether. So why it is so? This is because of the 8 electron system of metal. That is, valence shell contains 18 electrons in the contains, means there is capacity or there is presence of d orbital in Fe, and this Al does not have the d orbital. So the 8 electron system and 18 electron system is shown here. Then we will see another example, that is covalent characters. Covalent characters. So we can explain the covalent characters in number of such examples. For example, if we take NaCl, then MgCl2, AlCl3 and SiCl4. So here we will find that the covalent characters are increasing in this direction. Similarly, you will find that another example, that is HF, H2O, NH3, CH4. Here also you will find that the covalent characters are increasing in this direction because the anion is here monovalent, F minus, H, oxygen is 2 minus. So we can show here anion, that is -1, -2, -3, and carbon is with -4 charge. So these are some examples showing the series, that is covalent characters. Then we can have another example, that is HF, HB, HCl, HBr and HI. So this series also shows same type of trend, that is organic covalent characters are increasing in this direction. Now we will see many such examples are also available. Now we will see the next point, that is polarizing power of cations. Polarizing power of cations. So here we can take the example of alkali metals, that is group 1A or group 1 we can say. So here we take the example of alkali metal, that is Li plus, Na plus, K plus, Rb plus, Cesium plus. So here you will find that the size increases in this direction, and the polarizing power of cation, polarizing power of cation decreases. In this direction. Similarly, you will find that if we see the decomposition temperature of this, so the most covalent is this lithium compounds, and therefore its decomposition temperature is less. So the decomposition temperature is increases in this direction. So polarizing power has its effect on the decomposition temperature of the compounds of this alkali metals. Now we can have such number of examples. Then we will see the next property, that is thermal stability. Thermal stability. So the compounds containing, we will see the examples, that is BeCO3, MgCO3, then CaCO3, SrCO3 and BaCO3. These are the carbonates of the various metal ions, that is alkaline earth metals. Then you will find that the carbonate is same, but the cation size is different. So covalent characters are increasing in this direction, and because of this the thermal stability also decreases. So thermal stability depends upon this, the covalent characters. So you find that the thermal stability is observed here, it is most stable, and the thermal stability decreases in this direction. Decrease. And this is least stable. Means after heating, the carbon dioxide will be eliminated easily in case of barium carbonate. So that is why it is thermally less stable. Whereas this is more stable. And so in this way we can explain the thermal stability. Now we will see the next point, that is ionic characters. That is ionic characters. That is application of this Fajan rules in covalent solids. So if we consider a simple structure of this A, B. So here if we consider the atom A and atom B, then the electronegativity values of A can be shown as, can be represented as XA, and electronegativity of B is XB. Then we will show that the ionic characters or covalent characters depend upon the difference between the electronegativities of A and B. So we will see the first condition, that is when XA minus XB is equal to 0, means that there is no electronegativity difference. Then we say that such compounds are homonuclear diatomic molecules. So that is why their electronegativities are same. Now if we consider the second condition, that is XA, that is electronegativity difference, XA minus XB is equal to small, that is smaller value of these electronegativities. Then we say that such compounds are covalent. Such compounds are covalent. Covalent compounds or molecules. And third condition, we will see that when XA minus this XB is equal to large, so the electronegativity difference is larger, then such compounds are ionic in nature or ionic solids. So in such case, you will find that the electron of A, so in such case, you will find that the electron of A is completely transferred from A to B. Electron is completely transferred, so it becomes cation and it becomes anion. And that is why it shows ionic character. So this, in such case, when XA minus XB is large, the compound is ionic because the electron transfer takes place from A to B. So with this, we'll stop our discussion and we'll see the next point in the next lecture. So till then, goodbye. Keep watching this video channel and subscribe to this channel, and please press the like button and bell icon button. So thank you very much. See you next time.